Sorry, I know that many of you were waiting for my video regarding the one for those University of Port Harcourt and other university experiment M1. Um, Before I bring up the solution to that very practicals, I wish we should be able to understand how to use vernier caliper and micrometer screw gauge. Okay, so this first video is going to be on vernier caliper, how to read vernier caliper, how to use it to do measurements, and how to also read the scale properly. All right, so before I commence the video, please, I want you to hit the subscription button for those of you who have not subscribed. Okay, then also turn the notification bell, and of course share the video to your classmates and then those of them that are not in this group. And don't forget to join my platform where I take all your question and answers. But however, you are always also advised to drop any comments on the comment section, to keep the comment section in the YouTube channel here busy. I'm always there to respond to you. Is that okay? All right, so if you have not joined my WhatsApp group, the number to join is 09157 So take it down, chat me up. I'll add you to the WhatsApp group where you can meet with other of your classmates and as the case may be. Okay, so the practical that I'm looking at, let me just show what we are looking at today. Show you what we are looking at today. Okay, like we're looking at today is on M1. It's on M1. M1. Okay, I think let me go to, this is the manual we are using as usual for 2023-2024 sets. Okay, your university manual may not be like this, but what is inside? Okay, let me go to my cam scanner where I've done all the scanning of the job. Okay, the solution and everything. All right, just wanted to know what we are doing so that you a direction to where we are actually going. Okay, so this is the solution material which I'm using in my next video. So I'll be doing a video on vernier caliper like you have seen here, and also on micrometer screw gauge. Then once I'm done with that, we'll now come into the solution, like solving, explaining the solution that I've done here. And one thing you need to know, which I've been saying for those of you that are WhatsApp group, okay, I've told you that if you don't follow up this video, this very one, there's going to be 3 videos. The first one is going to be on vernier caliper. Second one is going to be on micrometer screw gauge, and then the last one will now be the solution explanation. If you don't follow up these 3 videos, you may not actually follow up the the material properly. Okay, so that means the video is very, very important. So this is what we have here. M1 experiment M1, which is a measurements of length with vernier calipers and micrometer screw gauge. Please, if your video is not that clear, if the thing is showing very blurred, that means that your video is not in high quality. So what you do, the screen of the video, because this is mobile, I use my phone to do the live session. So tap on the screen, on your screen while you are on YouTube. You see the setting icon on the top right hand corner of your video, of your YouTube video. Then tap it, you see some quality settings and the rest of them. So you can choose high quality, or you can choose 720, 420. But 720 high quality will be okay for you to have a very good experience, a very good view on this write-up. Okay, so like as I can see the write-up very well, I can read it very well. But if you cannot see it, you have to do that so that to enable you see it very clearly. Though I'll be zooming some part for you to see. Okay, so we have here the vernier caliper, and then we also have here the micrometer screw gauge. Okay, so we go to this thing, we'll be able to see them one after the other. Okay, so these are what we want to have. We'll be measuring, you can see it here. The same method, identify your specimen as sample A, which is the ball bearing, sample B, which is what copper wires, and then sample C for the block of wood, and then the rest of them. So I'll be going in detail when I come to the solution section of this very properly. So I just want to show you what this vernier caliper, or why you need to learn these parts, or why you need to pay attention to this very video, and then the other one too before we come to this one properly. So these are the tables that we are going to be filling. Consider the tables are very many. This is 1, and this is 2, 3, 4, 5, and then 6. There are about 6 tables that you must do. The work is very, very long. Like the physical class I had, it was over 4 hours class we had, okay, on Saturday, 9th, 2024. So that is March 9th, 2024. It was very, very long. So you actually, these are the solutions that we have. So if you don't follow up the video properly and you want to rely on the material, then you will not go far with this solution. Okay, so these are the conclusion of the whole thing. Okay, so this is the vernier caliper itself. This is the vernier caliper itself. Okay, you can see the part, the anvil, the spindle, the anvil, and yeah, the spindle. Between the anvil and the spindle is where you put your measurement face with your workpiece. Then you also have the barrel, which is where you read your main scale. You have the sleeve, which is where you read your sleeve or your thimble. Sorry, your barrel or your sleeve, which is where you read your main scale. Then your thimble, where you read your circular scale. Okay, and then the ratchet stop, where you tight up the whole stuff. So you can see I screenshotted it on Google. Okay, to get that. Then you also see a sample of the micrometer screw. When I get that, I will still show us that. Okay, I just needed to put this in the this thing in the picture. Okay, so that we'll be able to see what we have there. Okay, so I'll quickly go over to the YouTube. Okay, now I will be using a video from the YouTube channel from Learn Stock Videos. Okay, so I have no copyright with that. I want to reference or acknowledge Learn Stock Video for doing a great job. I've gone through so many other videos, but I think a Learn Stock Video make the whole thing very simplified. So I'll be using their videos because I don't really have the apparatus here, though I have it, the one I used to demonstrate in class, but it's my office, so I don't really have it here. So I feel I should information and explanation. So you just feel free to go to the video, and then you can also check more of his video over there. So I've saved the video in my playlist, so I'll be heading towards there to bring up the video. These are the videos I've also watched on that area. Okay, so I'll be going to my playlists. We're going to my playlist. This is my this thing. Okay, so you can see Learn Stuff videos here on my history. I've just watched the videos, so I've gone through lots of videos on micrometer screw gauge, so, and the vernier caliper. I'll be going through some of them, but let me start with the Learn Stock video. All right, so this is some Learn Stock videos. I'll be playing that of vernier caliper so that you can see how the vernier caliper is being used. Okay, so you just wait for it. I'll be doing some reaction concerning that.
Finally, add the
Okay,
main scale
let me
and the
start from the
vernier
beginning
scale.
because I've already been watching the video. So I'll start it from the. Okay, so this is what I was saying. If the video is not clear, tap on this icon. Okay, then this CC. If the
Hello
video,
and welcome back
okay,
to
now
Learn
the
Stock
video is
Videos.
showing
This video talks about
some
how to
captions,
read a
so I don't
vernier
want this caption
caliper.
to be shown,
But
so
before we
not to
begin,
block
don't forget to hit that
the video.
subscribe button
So I'll
and
tap on
ring
the
the
CC.
notification bell to
Can see
stay
the
updated
reason has
on our
disappeared.
captivating
The
science content.
subtitles
Let's
caption
dive
has
right in.
disappeared.
A vernier caliper is an instrument used to measure length. It measures the length of objects with short lengths, such as the diameter of a pen or the diameter of a water tap.
Okay.
A vernier caliper consists of the main scale, the vernier scale, and two jaws, the
Very
outer
important. The
jaws
main scale and the
and
vernier
the
scale
inner
is what you
jaws.
should focus on.
The outer jaw is used to
That's where
measure
we are
the
going to take
external
our measurements.
diameters of objects, such as the diameter of a pen. The inner jaw is used to measure the internal diameters of objects, such as the internal diameter of a water tap. How do you read a vernier caliper? For instance, given this vernier caliper, what is its...
If you have not subscribed, hit the
Before
subscription
reading a
button.
vernier
If you have not
caliper,
subscribed,
first
just hit the
identify the
subscription
main
button,
scale
please.
and the vernier scale.
Then see share the video too.
The main scale is placed on top, so this is the main scale. The vernier scale is placed at the bottom, so this is the vernier scale.
Okay.
Read the main scale by reading the mark on the main scale before the vernier scale's 0 mark.
Okay, so what that means is that you are going to read your main scale and stop immediately where you have that 0 mark on the vernier scale. The vernier scale is down. You can see the 0 down here. The 0, 5, 10 is the vernier scale. While the 4, 3, 4, 5, okay, remember it's just a section of the instrument that is projecting here. So you read your value and stop. See where the arrow is. That arrow where you put the main scale, you stop there. Okay, that's where you stop on the main scale reading. Then on the vernier scale reading, you check a value that coincides with that of the main scale, as it's going to explain. So please just look at the video very well and see what Learn Stuff Videos is actually doing there. Thumbs up for you, please, Learn Stuff Videos.
In this case, the main scale equals 3.1 centimeters. Read the vernier scale by reading the mark on the vernier scale in line with the main scale. Multiply the value by 0.01 if the scale is in centimeters or 0.1 if the scale is in millimeters.
Okay, I want to say something here, please, because if you were in my class, okay, for those that joined my class during the live session or the physical session, there's something we said which was somehow confusing to some students, and I told them, please, when you go to the lab, look at the vernier caliper or the micrometer screw gauge that you'll be given. That decides on this multiplication factor that Learn Stuff video is talking about. Okay, so now if you look at the main scale reading, the main scale reading is 3.1 cm. Usually the vernier caliper usually measured in centimeter. Okay, and then sometimes the vernier scale is also called a fractional scale, and sometimes it is in centimeter and sometimes millimeter. All right, so that's the point he's saying. Say now, if you look at the main scale, sorry, you look at the vernier scale or the micrometer screw gauge, you see a particular factor written on the body. You either see 0.01 millimeter or 0.01 cm. Okay, usually written on the body. Just check the body, the face of it. You see where it's written either at that vernier scale or towards the tail of that main scale. You see 0.01 or 0.02 or 0.1 millimeter, as the case may be. So he's saying that if it's in centimeter, then you're going to have 0.01 cm multiplied by the value that coincide on the main scale. But if it's in millimeter, you're going to have 0.1 millimeter. So whatever value that coincide from the main scale, that where the main scale and the vernier scale coincide, you are going to multiply that value by that 0.01 cm or 0.1 millimeter, as the case may be. But that is being decided on the factor that is being given to you on the body of that very instrument.
In this case, the vernier scale equals 2 centimeters. Multiplying the value by 0.01 gives 0.02 centimeters as the vernier scale reading.
So if you look now, the number there where he put the vernier scale, you can see that is 2. That 2 coincide with that 2 there where he put that arrow where he put vernier scale and then start doing the calculation. That is the number, that is the scale that coincide with the main scale on top. That is the 2 is below, which is the vernier scale. Then above it is the main scale. All right. So that video, sorry, I said that video. That scale coincide with that one on top. So that's why using the 2 to multiply by 0.01, since the main scale is given in centimeter. But if it's given in millimeter, you now do the conversion, which is almost like times 10, okay, of that, which is 0.1 millimeter. Is that okay? All right. Now, another thing again I want to say here, okay, is that sometimes, even while we're in the physical class, you notice that it will look as if about 2 or 3, yeah, somebody has a question, 2 or 3 scale are coinciding with the one on the main scale. And somebody asked me, what if we have 2 or 3? I said it's not possible. It is either that very apparatus is faulty, that very caliper is faulty, that means it has a very large zero error, or you did not screw it very well, did not tighten that object very well. So what you do is that just try to tighten the object. One more step will shift all of them, remain only one good one. All right, one proper one or one correct one, if I may say. Do you understand? So you cannot have two or 3 or 4 or 5 that coincide. No. If you see such case, then it means that you did not tighten that very object or that workpiece properly. So make sure you do that.
Finally, add the main scale and the vernier scale. Therefore, the final reading equals the main scale plus the vernier scale reading.
So to get a
the main scale reading equals 3.1 centimeters and the vernier scale reading equals 0.02 centimeters.
So when you add up
3.1 plus 0.02 gives 3.12 centimeters.
Yes, you can
so
convert
the reading
to
of this vernier caliper is...
All right, so now after getting your value, for example, let's use the video that Learn Stuff videos have got, the scale or the measurement that Learn Scale videos got here in this video as 3.12 centimeter. Now if you go back, let me say this lest I forget, okay, if you go back to your video, to your to your the table of value which you were asked to complete on that very experiment. Okay, you see that you were asked to measure in millimeter, because the essence of that experiment is to compare the measurements of those workpieces or workpiece. I'm using vernier caliper and micrometer screw gauge, so that at the end they will be able to know which one is more accurate. Okay, let's forget about the standard that we all know that. Okay, we have been told that vernier micrometer screw gauge is more accurate, but we want to check practically how true is it. Okay, so now what you do is that you're going to multiply this 3.12 by 10. That'll give 31.20 millimeter. So your value is going to be recorded in millimeter, because you have recorded centimeter from vernier caliper. But then before you put it on the table, you multiply by 10. Okay, you don't need to show that working, just do it on your calculator and then you put your answer. Now, micrometer screw gauge, as we are going to come in, is usually millimeter, because it measures much smaller object than vernier caliper. Are we all there? So what you do is that you are going to now multiply that value you got here in vernier caliper by 10, so that it will rhyme with that you are going to get in what? In your micrometer screw gauge. Is that okay? All right, let's continue.
3.12 centimeters. The second example.
Okay.
Find the reading of this caliper. The main scale equals 5.
Okay, so as you can see that the main scale equals to what? 5.3. Okay, before we play the video, the main scale is 5.3, just before the 0 on the vernier scale. Then the vernier scale, you can check, okay, his hand has covered some part. Okay, if you check just the number after the 5, I think that should be the number, that is 6 centimeter, which you multiply by 0.01, then add them up together. So you're going to get 5.3 plus 0.06, which is about 5.36 centimeter. That's what you are going to get under this. So let's see what is going to get there.
0.3 centimeters, the mark which is before the 0 mark of the vernier scale.
That's correct.
The vernier scale equals 6, the mark which is in line with the main scale.
Yes, that's correct.
Multiplying the value by 0.01 gives 0.06 centimeters as the vernier scale.
That's correct.
The final reading equals the main scale plus the vernier scale reading. The main scale equals 5.3 centimeters and the vernier scale equals 0.06 centimeters. 5.3 plus 0.06 gives 5.36 centimeters. So the reading of this vernier caliper is 5.36 centimeters.
Okay.
The last example.
Okay.
What is the reading of this vernier caliper? The main.
Okay. All right. So if you know the answer to this very one here, just hit it on the comment section. Okay. If you need the answer to this very one, you hit it on the comment section. I want to see the answer rolling, and then the first 5 persons, you get your mark for me. Okay, so do that. Let me see that on the list. So now I will also that's okay. So I will also move to show you few other videos on this. Okay, few other videos on this. Okay, few other videos on this, so that you'll be able to appreciate this section before.
How to read. Vernier caliper. Read the line on the main scale that's in line with the 0 on the vernier scale.
Okay.
And then find the first mark on the vernier scale that lines up with a line on.
Okay, sorry.
How to read. Vernier caliper. Read the line on the main scale that's in line with the 0 on the vernier scale, and then find the first mark on the vernier scale that lines up with a line on the main scale. How to read. Vernier caliper.
Okay, that was just a very short video.
How to read.
On this.
Vernier caliper.
Okay, I think with this we can move on to micrometer screw gauge. In the next video, I'll be doing that on micrometer screw gauge. Okay. Yes, there's another one again I also had here from ITI's junction. Let me see if I can play that. Yeah, let's see this one here. Okay. Okay, let's see this one. This one is practically showing you how the vernier caliper.
Now we'll work with a vernier caliper. The way this works is that there is again an upper and a lower scale.
Okay, just you
Here,
can
this is the centimeters.
this is
0,
exactly how
1,
the vernier
2,
caliper
3
looks like.
on this
So you can
axis
see
here.
that this one is real time.
And then on the upper we have
This
inches,
is the
which
real
we're going to neglect
vernier
for
caliper, how it looks
use.
like.
And then this
We're
is
in
the
class on
lower scale
on
down here,
the 9th
0,
of
1,
March.
2, 3
I
up
brought
to
it to the
9.
class then,
And
then
then
we saw
0
it.
again is the minor scale.
So you can see down here is the
When
vernier
it's
scale.
shut,
Up there
the vernier caliper
is the
isn't
vernier
measuring
scale.
anything that is then the zeros on the...
Now, please, I need to say this again, that if you look at the video, so if you look at the apparatus, you see scale up and scale down on that main scale. That scale up is in inches, while the one down is in millimeter or in centimeters, the case may be. So we don't use that of inches, we use that one of a millimeter or centimeter, which is the one down. All right. So make sure you don't mistaken it for another thing, so that you don't make mistake while taking the reading.
Major and minor axes line up. So we can see that this 0 is on the major scale, they line up quite well.
All right, now there's something new that this video was the video this in. I give credit to MST Council grade students, okay? MST Council's grade students, okay, YouTube channel. I give credit to them. So you can see that the first thing you're supposed to do is to check your zero error. Now, how do you check your error in vernier caliper? You ensure that you tighten up the jaws, okay? Just tighten up, just like what it's doing, tighten up everything and ensure that the 0 on the vernier scale, which is the one down, coincide with the 0 on the main scale. That's the first thing you must do. If the thing that did not coincide, then you are going to have issue with your measurements. Yes, that's the first thing you're supposed to do. The same thing you do also for that of micrometer screwage. By the time we get there, I will still show you. So he did a very nice job here.
No.
So you can see that is the reason why you need to go through different videos, okay? And I love this pattern of doing reaction videos on different videos to enable you get proper understanding. So one video is not enough, just like our textbook. One textbook will not be enough for you. So you read three different videos, textbooks, or four different videos, as the case may be, to enable you get understanding of what you are actually doing.
Where else does it occur? That is the markings on the minor and major scale lineup, except again at 0 here and there.
Yes, the last 0 there is 10. Usually we have
We'll
1 to 10.
put our measurement object here between the teeth of the vernier scale, and we'll close it. When we're measuring something, there's a flat side here, and we'll want to put our device in that, and then close it with a little bit of pressure. And with that value, we're going to see what the measurement is. On the major scale, it's the question of where does the 0 on the minor scale line up with the major scale. So here we have a 0 on the minor scale, which is a little past this hash mark here. So that's 5, 6, 7. It's a little more than 0.7 centimeters. The question is, how much more than 0.7 centimeters is it? Since the 0 here doesn't line up with the major scale exactly, we need to find where on the minor scale it does. So there's no match here until we reach, say, the 6 value. So on the minor scale, the 6 mark lines up pretty well. You could even say the 7 mark lines up better.
So that was what I said.
So we'll take this 7.
I said something during when I was looking at the lens stop videos. I said sometimes it looks as if maybe two line are coinciding. So you can see he showed you that of 6 and that of 7. They're almost coinciding. So you have to be very, very careful. So if you watch now, he didn't tight his distance very well. He just uses one hand because he's using one hand to do the video, and then use one hand to do the measurement. So that's why it was not properly tight. If he goes back again to tighten up that stuff, you notice that one of them is going to shift. So let's go back.
As our minor scale. Now the question is, how do we combine this 0.7 centimeter measurement on the major scale with the 7 mark on the minor scale? The answer to that is over on the far side of our caliper. There's a little marking that says
this is nice.
0.
This is nice. So this was what exactly, see, that's why it's good to go through different videos, YouTube videos on YouTube channel, all right? So I tell you that if you look at the tail of that very instrument, of this vernier caliper, you will see it there. So here is 0.05 millimeter. like that is a factor on the main scale, sorry, on the vernier scale, while on the main scale is what is just read there, that is 0.7. So what, check, see what is going to do with this 0.05 millimeter. Now in the other one it was 0.01, but here 0.05. You understand? So it varies, okay? Based on the size of that instrument, they are going to decide the factor on the fractional scale, which is the vernier scale. So let's see what it's going to do with that 0.05.
0.05 millimeters. This tells us the smallest unit of measurement for the caliper. So now when we look back, this 0 on the minor scale is somewhere between 0.7 and 0.8 on the major scale. So this gives us some confidence that our measure is correct. Now that we know the smallest unit of measure on the minor scale is 0.05 millimeters, that tells us what this 7 means. Each of these small marks from here to here is 0.05 millimeters. And so since this is 7, and then there are 2 marks per increment, there are actually 14 of these small measurements.
Okay.
The way we'll combine these sets of measurements, the 0.05 millimeters on the minor scale as the smallest measurement with the major scale of 0.7 centimeters, is we'll take the major plus the number of minor increments, in this case 14, and then multiply that number times the smallest measure. So what we get back after we convert to the correct units of centimeters, in this case, is 0.77 centimeters, with an accuracy of plus or minus 0.005 centimeters.
So if you check what he did there, okay, it might look very confusing. If you count the numbers, if you count those scale from that 0 to that 7, if you count each of those small divisions, it's about 14. And that 14 times 0.05, which is that factor, I get me now, is 0.07. But if you now go back, if you go back to what Learn Stuff video says, it's almost the same thing. Because that is the normal one that we all know, you understand? Now, if you multiply 7 by 0.01, what are you going to get? You get 0.07. So if you know how to measure that, if you understand what that vernier, the smallest division stand for, you should be able to manipulate the other parts, you understand? So generally, the least number you get is usually 0.01. So multiplying that 7 by 0.01 will still give 0.07. So you add 0.7 on the main plus 0.07 on the vernier scale. So let's see another example again, as he's going to take us to the next example.
As a check, this makes sense because the value should be between 0.7 centimeters and 0.8 centimeters. And if we look back at our original measurement, we see that our 0 mark on the minor scale is close to the 0.8. So 0.77 centimeters makes sense. Now, as an example of what happens if our scale is slightly different, if we're using a different measure, and we come up upon the case where the 0 on the minor scale lines up with an increment on the major scale. For instance, now I see that the 0 on the minor scale lines up very well with 1.7 on the major scale.
1.7.
What that does for our calculation is we still have a major scale of 1.7 centimeters, but now our minor measurement is 0 increments, and we multiply that times our smallest measure of 0.05 millimeters, and what we get back is a more precise measure of 1.70 plus or minus 0.005 centimeters.
Okay, so we'll stop here. All right, so this video might look somehow confusing, but make sure you follow what I
Hello and welcome to the video. This is a video about this precision instrument.
Okay, this was exactly the one I have.
This is a vernier caliper. Now, if you watch YouTube and how-to videos on a regular basis, you'll have seen a version of this. Probably not the same as this. It'll have a little screen on it and a couple of buttons, and it'll be there's probably not a lot of people that I know would know how to read this thing.
I thought I would make this.
So how does it measure so fantastically accurately when essentially...
Check down, you see 0.02. That's the factor for this one. You can see that it is being written down, like I've told you, 0.02. That's the factor for this very one here.
Just a ruler with a slidey bit. Well, if we zoom in, the slidey bit is actually graduated. here at the bottom, you can see that there's these different graduations, and these are marked off in 0.02 millimeters. So how does having this bit printing down here and the normal kind of measurements printed up here actually get you close to being able to measure up down to 0.02 millimeters just by using the sliding pieces? So I thought, let me give you a practical illustration. Let me measure the outside of this peanut camera, and we'll actually have a look. So now it's measured. Let me zoom in and show you what this looks like. So here is the measurement. Now, where you actually read the measurement off is at the 0 place. That will tell you where you're up to. So here we can see slightly out of kilter because the camera's actually looking at this bit, and these pieces are beveled. But trust me, this 0 is exactly aligned with this line here, so we know it's 24 millimeters exactly.
Okay, this is in millimeter.
Okay, does that really help us? Well, what we're looking for is which of the lines on here actually match up with the lines on here.
So you can see that him is reading in millimeter directly. So that is 2.4 cm, which is what? Times 10 will give you millimeter, 24 millimeters. So it's still the same thing. So it all depends on what you are doing. But I said what you should be recording is going to be millimeter on your table of value.
Because at the moment, the best fit is actually right here at the 0 point. So we can pretty much positively say it's 24 millimeters. Now, if we take another measurement, and this time we measure the other dimension of the peanut camera, then let's zoom in here and have another look. Again, it's slightly out of kilter because you have to adjust for the fact that unfortunately we're having a bit of distortion because of the closest to the camera to get a nice picture for you to have a look at. Now we can see here that it's 54 millimeters,
which is 5.4 cm.
but it's actually not. This line does not match up. So what we do is we know it's almost 54 millimeters. So which of these lines is most closely matching? And we can see here that the 2 isn't matching, the 3 isn't matching, the 4 isn't matching, neither the 5, 6 or 7. The 8, as we're getting up here, it's getting closer and closer and closer. And here, the 9 is almost, but down here, let's say that this is the line that's actually spot on. So now we know that it's 9, 4, because each of these graduations is 0.02. So this is 53.94 millimeters in diameter.
Okay.
Makes
It's all right. So, well, he didn't show his write-up so that you follow, but he's just adding it like an expert. Okay, so every of his work is in millimeter. So that 9 times 0.1 will give you 0.9 millimeters. So if you add it up to the other value, that will give you that 53.9 millimeter that he actually said. Okay, so for now we'll end the live session this video for this very one. For those of you that are online with me, streaming that with me, please drop a comment section, drop your phone number. Also, I want to celebrate you. Is that okay? So just drop it. Now this is 8:25 a.m. Monday, March 11th, 2024. And I'm glad that you also joined me in this live session. Don't forget, the next video on micrometer screw gauge is coming, and the essence of this is for us to give our students the best in all our Nigerian university, and of course Uniport in particular. So make sure you follow us. Follow me in my check other YouTube channel. I check other YouTube videos that I've made concerning physics practicals, and of course Mass 120, Mass 102, which we call Mass 120, Mass 101, which we call Mass 110 then, okay? And of course Phys 101, Phys practical, and the rest of them. Then any question you have, please don't forget my phone number 09157293443. You can join the WhatsApp group. Then please, if you've not subscribed, please hit the subscription button right now. And then if you have not shared the video, please make share the video to every other of your classmates, your classmates, and every other person that you know will be interested in this video. For now, I want to say have a wonderful day as we move on to our next video on micrometer screw gauge.